All right, so before we do systems, we need to convert the word problems. Again, these are gonna be always the trickiest bits about any math question. Converting the words into equations. So let's see. So this is what they've given us. Again, you know it's gonna be a system. What are the two equations for this? What do you think? So we're mixing two different types into a cookie. So let chocolate chip be X, okay? Let this be Y. And notice we have one for butter, and we have one for oatmeal. So what are the two equations? It's pretty simple if you see the pattern here.
You just add them?
Yeah, so it'll be 13x plus 2y equals 47. That's for the butter. And 8x plus 29y, and that's for the oatmeal. All right. How do we solve this system? What would be the best method to solve this system? How do you even solve a substitution? They would both work. If you use substitution, what happens is that you end up with fractions.
So elimination?
You can do both. I'm going to show you how to do both. Okay, if you do elimination, how do we proceed with that? You're going to have to make one of the coefficients, either x or y, the same. Let me just see if this equation, maybe we flipped it. 13x. No, we didn't. These are very weird numbers because we have two prime numbers, we have three prime numbers, and this is going to make it super awkward to use anything. But let's use elimination. I think it's best because then you don't have fractions. To use elimination, you have to make one of the coefficients the same. So 13 and 8. The LCD between 13 and 8 is just 13 times 8, which is 142. So I'm going to multiply this entire first equation by 8. And I'm going to multiply this entire equation by 13. And that's going to give us our two equations. So we get 104x plus 16y. That's going to be equals to 8 times 47, which is 376. And down here we have 104x plus 29 times 13, which is 377. That's going to be 143 times 13. That's going to be a huge number, 1820. What do we do next? Once we have the same coefficients. Notice how the x's, we have 104 for both of them.
You subtract?
Yeah, you would subtract, and hopefully we get a nice number. So 16 minus 377, negative 364, and on the other side, 376 minus 1820, that's negative 1444. There's a y here. This divided by negative 364, y is 4. It's like 3.96, but it's basically 4. Now that we know y, how do we solve for x?
You can plug in y into either of those equations.
You can plug it into, we have 4 equations here. We could plug it into any of them. I think this would be the easiest one. So it'll be 2 times 4. So we have 13x is 47 minus 8. So 47 minus 8 divided by 13, we get x is 3. And you are done. Cool? So probably substitution is probably going to be a little bit more difficult here, simply because you have fractions. And the fractions are weird prime numbers as well. So elimination is probably the best way for this question. Sometimes it'll outright tell you to use something, but here they don't. But again, if you see something like this, I think elimination is better. What about this one? Which one would be better, substitution or elimination? They both work. It's not like one is not going to work, but one of them is more efficient than the other. Here, let me show you a substitution for this one, and you'll see why it's probably not the best. Substitution is best if any of your four coefficients is a 1. Then you can easily write x in terms of y by just throwing things around. Let's say this was a minus y, then you would have y is equals to 7x minus 42, and you can replace this here. The substitution is probably best if you have one of the coefficients as 1, but let's try doing it here. To use elimination though, you'd multiply this by 3 and this by 2, and you can cancel out the y's. That would be the quickest, but let me just show you the substitution also works. It's just a little bit trickier. I'm going to work on this one. Let's solve the second equation for y. What is y going to be in the second equation if you want to isolate it? So we only want y on
You subtract 17x and then you divide by 8.
Right, so it'll be -2 minus 17x divided by 8. So that's our substitution. And then we're going to replace this with this over here. Then you have 7x minus 12 times -2 minus 17x divided by 8 equals 42. How do we solve this equation for x?
You open the bracket.
All right, if you open the bracket, would you multiply the denominator by 12?
No.
No, you would not. So you get -12 times -2 is plus 24. And -12 times 17 is 198. Yeah. Oh, no, it's not. It's 204. So 204x over 8 is equals to 42. Now what? We're trying to solve this for x. There's a fraction. What do we do when we see a fraction in an equation? You do LCD. You want to combine them.
Mm-hmm.
So here you'd multiply this by 8 on the top and on the bottom. 8 times 7 is 56. You can add this with 204. So you get 260x plus 24 over 8 is equals to 42. Now what?
You multiply by 8.
You multiply by 8, you subtract 24, and then you divide by 260. You get x is 1.2, and then you can plug it in over here. So -2 times 17 times 1.2 over 8 to solve for y. Times -17 times 1.2 divided by 8, and that gives me 5.1 as y. And that is the answer. Cool?
Mm-hmm.
So it does work, but I think sometimes it's best to use elimination. I don't know, it really depends. Let's try this one. All right. So we don't have equations given, so we need to turn this into an equation or two. It's going to be a system of equation. One of them, again, you want to pay attention to the information they've given us. One of them will be time, and one of them will be distance. What should our x and y be? That's gonna define how we solve this problem. What is f and x and y here?
Whether the submarine is traveling on surface or underwater.
So is that the time or distance in those locations? So how far? I guess we can say it's distance. So let's say surface is x, the distance, underwater is y, okay?
Mm-hmm.
So they're traveling 200 kilometers total. Let's say this is x. 200 is the total. On the surface, it traveled x. How much is it going to travel underwater in terms of x? What is this distance from here to here in terms of x?
200 minus x.
Yeah, 200 minus x. So we're given a time. So time is 12, right?
Mm-hmm.
What's the formula for time in terms of distance and speed?
It's distance over speed.
It's distance over speed. So distance on the surface is x. The speed in the surface is 20, right? And similarly, we have distance in underwater is 200 minus x, and the speed is 10. There we go. That's going to be our equation. There's other ways to do this depending on what you say your x and y is. Since we're saying x and y is distance, this is the equation that we end up with. How do you solve this equation for x? Again, we have a fraction.
So you multiply the other one by 2.
So you would multiply this by 2 and 2. That'll give you x plus 400 minus 2x over 20 equals 12. Now what?
You multiply by 20.
That's 240, 400 minus x. So x will be 240 minus 400. That's going to be negative 160. So x is 160. What's y if x is 160? What's the distance
It's
traveled?
40.
It's 40 and you're done. So again, we saw the trinity of distance, speed, and time again. So there's two people working here, the welder and his apprentice. The question is, what's their hourly wage? So when they work together for 3 and 5, they make 175. When they work together for 7 and 8, they make 346. The question is, what's the hourly rate? So what is the equation here? We should get two equations.
3x plus 5y equals 175.
What about the other one?
7x plus 8y equals 346.
346. So let's use what should we use? Probably elimination. They both work, like I've said multiple times. Let's solve for, let's kill y. So in a kill y, that means you need to make both of these coefficients the same. You need to multiply the top equation by 8. and you need to multiply the bottom equation by 5. Basically, the goal is to have the LCD be the same. So this becomes 24x plus 40y is equals to whatever that is. 1000 plus 400, 175 times 8, 1400. And this becomes 35x plus 40y is equals to 346 times 5, 1730. Do we add or subtract if we want to kill the y's?
You subtract.
You subtract. So this goes away. Negative 11x. Well, 1400 minus 1730 is negative 330 divided by 11. So x is 30. So that's the wage for whatever the welder. How do we find y? If we know
You
x.
just plug it in.
Yeah, you can plug it into any one of them. I'm gonna plug this as x here. So this becomes 90 plus 5y equals 175. So y is 175 minus 90 divided by 15. And that is not a nice number. What? That's 2 less, $5.67. And that is it for this question. Cool?
Mm-hmm.
I don't think I plugged it in right. What did I do? 3 times 30 plus 5y equals 175. So it's 175 minus 90, which is 85. I divided it by something else. I should have divided it by 5. The answer is actually 17 because 5.67 is 2 less of a
Yeah.
wage. So it was actually 17. That makes more sense. All right. In a walkathon, Lori and Nicholas walked 72.7 kilometers together. And it says Lori walked 8.9 kilometers farther than Nicholas. Create a linear system to model this equation. All right, so we're gonna get 2 equations out of this. So again, just it makes things easier if you just assume what x and y is. Let's say x is the distance Lori walked, and a y is the distance Nicholas walked. So we know they walked together in total 72.7. What's on the left side of this equation?
X plus Y.
Yeah, that's it. And now the second equation. Lori walked 8.5 kilometers farther than Nicholas. So let's say Nicholas walked y kilometers, okay?
Mm-hmm.
How much did Lori walk in terms of y? Plus 8.9 or minus 8.9?
Plus.
Plus. All right, so is this a substitution or elimination?
Substitution.
Yeah, it's a substitution. So it becomes y plus 8.9 plus y is equals to 72.7. Becomes 2y plus 8.9 equals 72.7, right?
Mm-hmm.
And from here, it's pretty simple. So it becomes 72.7 minus 8.9 divided by 2. So the answer for y is 31.9. And you can plug that in here to get x. Just add 8.9 to that. So the answer will be 40.8. And you are done. Easy enough. Here is a percent question. Again, there's just a little bit of a trick here. If you know the trick, then you're good to go. All right, so you're gonna come up with, there's gonna be a system of equations here. The goal is to find the two types of chocolates. He has a 99%, that's one type. The second type is 70%. What are our two equations? So one of them will be the mass equation.
So x plus y equals 500.
Yeah, x plus y equals 500. The other one will be the dollar equation, the cost equation. So what is it?
It's 0.99x.
Mhm.
And then 0.7y.
What's on the right side? Is it 500?
Times 0.86.
Yeah, this was not the dollar, this is the percent, but the idea is the same. It'll be 500 times 0.86. So is this a substitution or elimination?
Substitution.
Substitution will probably be easier here. So let's say x is 500 minus y. We can replace this. So 0.99 times, and we've done this a few times. That's going to be 500 times 0.86. That is 430. All right, now we have a linear equation. How do we solve this equation?
We open the brackets.
Yeah, you open the brackets, so 0.99 times 500. So that's 495 minus 0.99y plus 0.7y is 430. Negative 0.29y is equals to negative 65. So
divide.
you divide, this is going to be 224 grams. That means the other one is 376 grams. Or 276 grams. If they have to add up to 500. And you are done. That made sense? So just for this percent questions, yeah, this, if you know the trick, then it's pretty straightforward, honestly. It's not that bad. Let's try this, the one with a C on it. So someone's going for a run, Carl. He's going through paved trails and rough terrain. He runs 10 kilometers per hour on the trails, but his speed is reduced to 5 kilometers on the rough terrain. One day he ran 12 kilometers in an hour and a half. How far did he run on the rough terrain? All right, what's gonna be our x and y? That's gonna determine how we solve this problem. You're gonna get two equations. Hopefully. What's our x and y? Let's start with that.
Whether he was running on the paved trails or on the rough
You're right.
terrain.
So we know in total he ran 12 kilometers. So let's say the paved is X. What's gonna be his distance on the rough trail in terms of X?
12 minus X.
Yeah, 12 minus X. Now they've given us time, remember. So we will have something plus something equals 1.5. What is this equation gonna look like?
X over 10
Plus 12.5 distance
over 5.
There we go. So now this one's very simple from here. Multiply this by 2, multiply this by 2 to get the LCD.
Mm-hmm.
So we have x plus 24 minus 2x over 10 equals 1.5. We have negative x plus 24 equals 15. So x is 9. That means y will be 12 minus 9, 3. Just plug this over here to get what y is. That's going to be 3, and that's the answer to this question, and you're done. Easy peasy, right? Once you know how to do some of these, they're all pretty similar. Like, see if this one's any different. This one. Two fractions have denominators 3 and 4. Their sum is 17 over 12. If the numerators are switched, the sum is 3 over 2. Determine the two fractions. All right, this one looks to be a little bit trickier. Again, it's gonna depend on what your x and y is.
It's the numerators.
Sure, so the first one will be x over 3 plus y over 4. What does this add up to?
17 over 12.
What is the other equation?
Y over 4 minus X over 3 equals 3 over 2.
Maybe we should just write it as x over 4 plus y over 3.
Mm-hmm.
Let's write it like this. All right. How do we solve this? We have a system. We have two equations and we have two unknowns. So we can definitely solve this. What will be our approach?
Could you do elimination?
Okay, if you want to do elimination, what do we multiply this by? We need to make one of the coefficients the same so we can cancel it out. That's slightly tricky, right?
Mm-hmm.
So if you want to kill the x, you want to multiply the first equation by 4 and the second one by 3. So that you end up with the same thing. But I think the best thing to do here would be to get rid of all the fractions. Here, look at this method. What you do here is that you multiply both of these equations by the LCD of 3 and 4. Would that help? Let's see. So, or that's one approach. The second approach is you multiply this by a 3 and you multiply this by a 4. That will just give you 1x and 1x. So this will become an x, 3 over 3. This will become an x. This will become 3y over 4. This will become 51 over 12. This will become 4y over 3, and this will become 12 over 2, which is a 6. Let's try doing it this way. Now what do we do now that we have the same coefficient for x?
You subtract.
Yeah, you would subtract, so this goes away. So we have 3y over 4 subtract 4y over 3. And we have 51 over 2 subtract, this was 6. All right, now what? We're trying to solve
We
this
find the
equation.
LCD.
Yeah, we find the LCD, which is going to be 12, right?
Mm-hmm.
So you multiply this by 3, you multiply this by 4 on the top and bottom. You multiply this by 4 times 12. You multiply this by 12 on the top and bottom. So this will give you 9y minus 16y over 12. And on the other side, we have 51 minus 72. So we have negative 21 over 12. Can we cancel out these two 12s?
Yes.
Yeah. If you multiply by 12 on both sides, those two denominators disappear completely. Then you have this. So this is negative 7y is negative 21. That is 3. So y is 3. To solve for x, you can plug it in anywhere. I'm going to plug it in right here. So x plus 4 times 3 over 3 is 6. So x will be 6 minus 4, x is 2. And you're done. That's the end of the question. Did that make sense?
Mm-hmm.
So again, this one's not terribly difficult. It's just that you have to deal with fractions, and we know how to deal with fractions. Just take the LCD. It's not too complicated, especially when you have a calculator. It's slightly annoying, but not too difficult. Let's look at this one. So we had two kinds of meals. We have chicken meals at $12 and pasta at $8. The total cost of the dinner for 240 students is $2,100. How many chicken dinners did the students order and how many pasta dinners did they order? So we know what X and Y is. It's a number of types of dinners. What are our two equations?
The first one is x plus y equals 240.
What's the second one?
12x plus 8y.
Equals 21. That's the cost equation, right? This one's obviously a substitution equation. So x becomes 240 minus y. It's a substitution if any of the coefficients are 1, and then you solve for that coefficient that has a 1 in front. So here it doesn't matter if you solve for x and y. So x is 240 minus y. So it's going to be 12 times 240 minus y plus 8y. That's going to be 2100. Then you just plug it in. So you get 2880 minus 12y plus 8y is 2100. So this will be negative 4y is 2100 minus 2880. You basically get the answer. It's pretty simple once you know the thing. This is 195. That means this x is going to be 45. And that's the answer. 45 chicken, 195 pasta. That's it. Easy peasy. Try this one. The sum of the squares of two negative numbers is 74. The difference of their squares is 24. Find the two numbers. So our x and y are the two numbers.
So x squared plus y squared equals 74.
What's the other equation?
Y squared minus x squared, or no, x squared minus y squared equals 24.
You add or subtract?
You add?
You add, so you get 2x squared.
Is that right? You subtract?
It depends on what you want to cancel out. If you want to cancel out the y's, you can just add them, right? So here you can just add them. The goal is to cancel out one of the variables. Which one's easier? Here, I think if you just add them, it'll be easier. So this will become 98. So x squared is 49. And x is 7. Is that right? So y would be so now let's solve for y. Y squared is 74 minus x squared. So it's going to be the square root of 74 minus 49. Square root of 25 is y. So y is 5. Is this your answer to this question? No, it's not, because we're looking for negative numbers. X is -7, y is -5. Remember, the square of anything is going to be plus minus, right? Well, if you're solving for an unknown, that is. Square root of 49 by itself is 7. But if you have x squared equals 49, then x is going to be plus minus 7. This is slightly difficult to understand. It's because when you're solving for an unknown, you can have multiple possibilities. But if you square root of 49 by itself is 7. But the answer to this question is -7 and -5. Let's try this one. So first of all, we have how many unknowns in this system of linear equations? Potentially it's not even linear, but how many unknowns are there? No, there's only two unknowns. One of them is a combination, but in terms of the unknowns, x and y. If we have x and y, we can get the answer to both of these equations, right? So it's about the x's and y's. There's two unknowns. How many equations do we have?
Two.
Two. So this is a solvable system. If you had three unknowns but only two equations, that would not be solvable. But here we have two equations and two unknowns. We can solve this. But to solve this, which one should we eliminate? So we have 2xy plus 3 equals 4y, 3xy plus 2 equals 5y. Now notice this. If we somehow canceled out the y's, we're going to get an xy here, right? We'll get xy is equals to something. That doesn't really help us solve anything. So the goal here is not to kill the y first. You need to kill the xy. You need to get rid of that xy so that you have one known and then you can plug it in. Here, let me show you how this works. Because if you cancel out the y's, you'll be left with xy equals something, and that's not really solvable. So you have to cancel out the xy's. Let's use elimination, I guess. So 3 and 2 becomes 6xy plus 9 equals 4y. 6xy plus 4 equals 10y. This should have been 12y. So this is 10y. Do we add or subtract to kill the sixes?
Subtract.
Subtract. So we get 5 is equals to 2y, right? So y is 2.5. Now that we know y, we can solve for x by using either one of the equations. I'm going to plug that as y in here and in here in the first equation. So this becomes 2 times x times 2.5 plus 3 is equals to 4 times 2.5. 5x plus 3 is equals to 10. 5x is 7. And x is 7 over 5, and you're done. Cool?
Mm-hmm.
Do you understand why killing y first wouldn't work here? You have to get rid of the xy term first. Otherwise, you'll get, if you kill that y, you'll get xy is equals to something, and that doesn't help you at all.
Mm-hmm.
So here, the first thing to do is to solve for y by killing the xy's, and that's what we did. By killing, I mean eliminating. Let's try this one. We'll get the picture of the plane in as well, why not? So there are two jets coming into a runway in 15 minutes. So the airport has multiple runways, right? So it doesn't matter if usually what happens is one of them is always better than the other. One runway is more traffic heavy than the other runway, usually at more airports. So if some plane is coming from this direction, some plane is coming from this direction, they're both landing in 15 minutes. It doesn't matter if they come simultaneously, yeah? As long as they're landing in different runways. And it's not going to always be left, right? It can also be, the other runway could also be going perpendicularly this way. So it's okay for two planes to arrive at the same time. Sometimes what they do is they line up. If they're coming from the same runway, they would line up. So here the question is, are they coming from the same direction or not? How would we answer this question? He should alter it if they're on a collision course. Basically, if they're gonna collide, then he should definitely alter it. And if they are not, then I think he's good. That would be the answer. So how can we visualize whether they're gonna meet or not? Let's graph it. Easier said than done. So it's kind of annoying to graph this, but it's fine, whatever. Let me just Desmos this actually, because if you graph it, you're gonna get 6.66 or something.
Mm-hmm.
And that's, I don't really have the super graph paper, so I can't be that precise. Let's see what they look like. You know how to graph linear lines, right? You
Mm-hmm.
can either do the mx plus b approach, where you solve for y, or you can solve for the x and y intercepts. Actually, before we graph it, let's check for something. Are the y-intercepts for both of these the same? Just by quick evaluation. The y-intercept for this will be 20 over -5. That'll be -4. The y-intercept for this one will be -72 over 30, which is whatever, but it's not -4. So the y-intercepts are not the same, yeah? So that's step number one. Y-intercepts are not the same. What about the slopes? The slope for the top equation will be, and maybe we should rewrite it in mx plus b, so we don't even have to graph this. I'm gonna write both of them in terms of mx plus b. You'll see why. It's if you do it this way, you don't have to really graph it. So here, this will be 5y equals 3x minus 20. Y will be 3 over 5x minus 4. Here, 30y will be 18x minus 72. y will be 18 over 30, x minus 72 over 30. 18 over 30 is 3 out of 5x minus 2.6, I think that is. Let me just double check there, whatever. Divided by 30, 2.4, not 2.6. 2.4 equals y. So if you were to graph these, one of them will have -4 as the intercept. The slope is 3 over 5. The other one would have -2.4 as the intercept. And the slope is the same. What's the similarity between these two lines? Something is similar between both of them.
They're going in the same direction.
What is this?
The slope.
The slope. The slope is the same. The y-intercepts are different. So are these lines parallel?
Yes.
Yes, they are. Do parallel lines ever meet?
No,
No, they don't. So should he alter the direction?
he doesn't have to.
It doesn't have to, exactly. And that's done. Here, let's look at this page briefly. Which method is the best for solving linear equations? Use graphs if you don't need an exact answer. Graphs are not very precise, especially if your slopes or y-intercepts are decimal numbers, then you're never going to be precise with a graph. But it is good, it's a good tool to visualize what the solution could potentially look like. And it's super easy to graph something if it's in the form of mx plus b, right?
Mm-hmm.
Use substitution if any one of your coefficients in a system, you have 4 coefficients, x, x, y, y. If any one of them is a 1, substitution will probably be easier. If none of them are 1, then elimination will probably be easier. But all 3 of these work. Okay, that's
Mm-hmm.
getaway is 3 of them. All 3 of them work. You need to know how to do it all 3 methods, but sometimes one of them is more efficient than the other one. Let's try this one. So Gary picked up his truck from Cornwall. He's going to Chatham. Left at 8:15, drove at 100 kilometers per hour. All right, that's the story. What does the coordinate of the point 525.5 tell you about the amount of fuel? So this will be a C problem. C as in C for communication. The question's asking you, what does this point represent within the context of this problem? That's what it means. So if you had to explain this point, 525.5, to someone, how would you explain it to them?
After 5 hours, that was the amount of fuel left.
Exactly. How much fuel was left in the tank at 11:45? I don't think we have to be super precise because they've given us a graph. And we don't know what the y-intercept is anyways. So question B, how much fuel was left in the tank at 11:45? So we're looking for the y value when the x value is something. Remember, he left at 8:15. Time is the number of hours after he left. So how many hours have passed from 8:15 to 11:45?
It's 3.5.
3.5 exactly. So we're just looking for the y value when the x value is 3.5. So this is going to be an approximation because the graph is not super clear, but it's probably going to be like 36, 37 liters, right?
Mhm.
Depending, looking at it from that graph. The low fuel light came on when there was 6 liters of fuel left. At what time did this light come on? So how do we answer part C?
You can draw a line at 6.
Yeah, again, no one knows where that is precisely, but I'm just gonna eyeball it. Maybe somewhere there's 6. So it looks like around 7.5 hours have passed, right? So
Mhm.
that's gonna be at 3:45. And that's it. 4, 5, 6, 7, yeah, 3:45 sounds right. And that's the end of the question, 3:45 p.m. Again, if they give you a graph, you don't have to be super precise with it. That's just how it is. We've done this question, I think, before, or something very similar. Was the question with the cars with a K on it. But this is the same exact problem. So we have two choices, two options here between the rental companies. We can go with Ready Cars, which has a lower y-intercept, but it has a higher slope, right? This is Ready Cars, whereas the other one, the Best Cars, has a higher y-intercept, but has a relatively lower slope. So this is gonna be Best Cars, and they're gonna meet somewhere. At that point, it doesn't matter which one you pick.
Mhm.
So what's the strategy to solving this problem?
We need to find the point of intersection.
Right, it's pretty easy as well to do that. We've done this before. 59 plus a 0.14x will be the equation for r, the first y. The second y will be 69 plus 0.11x. How do we solve this equation for x?
You subtract 11x and then subtract 59.
This is not a nice number, but it doesn't matter. So it's going to be 10 over 0.03, which is like 333 kilometers. So we know this point, 333.33. If you use the car for this kilometers, it doesn't matter which one you go with because your price will end up becoming the same. So what advice would you give? Well, what would you tell this individual?
If you're gonna drive less than that amount, you should use the Ready Cars, but if you're gonna drive more, you should use the other one.
Right, perfect. That's it. You could probably use something like if you ever get, I don't know if you have a license, but if you ever want to rent a car, you can use this strategy as well. You can compare different services, right?
Mm-hmm.
We talked about this briefly. There's like the local one, and then there's like
Yeah.
so you can do that yourself as well. That's like a real life application of that. But usually, if you drive a lot, if you're going like across towns, then you should probably go with the one that gives you unlimited kilometers. That one would be the cheapest. So this is the same question basically. It's the exact same question, except now we have we're renting snowblowers. The first one has 20, the slope is 8. The next one has 12, but the slope is 10, right?
Mm-hmm.
So this one is Tools R Us, and this one is Randy. It's the exact same question. If we need to find the POI, if the POI, if you're renting it for less than that, go with the bottom one. If you're renting for more than that, you go with the top one. Plus 10x. So this becomes x is 10 over 2, x is 5. So that point is 5. So what advice would you give these people? It's the same question. If you're using it for 5 hours, it doesn't matter. Less than 5 hours, go with tools. More than 5 hours, go with Randy, right?
Mhm.
And that's it. All right, let's call it there for us for today.
Okay, thank you.
See ya.